For 25 years, scientists believed the universe was expanding faster and faster, driven by a mysterious force called dark energy. In 2025, the largest 3D map of the universe ever created revealed something that shouldn't be possible. The expansion is slowing down. Dark energy appears to be weakening. If this is real, everything we thought we knew about the fate of the universe is wrong. For a quarter of a century, one of the most fundamental facts in cosmology has been this: the universe is expanding, and that expansion is accelerating. The force behind it, called dark energy, was believed to be constant, an unchanging property of space itself. But in 2024 and 2025, a massive survey called DESI produced the largest three-dimensional map of the universe ever created. And what it found has shaken the foundations of modern physics. Dark energy may not be constant at all. It appears to be weakening. This is the story of what that means, and why it could change everything we think we know about the fate of the cosmos. In 1929, Edwin Hubble made one of the most important observations in the history of science. He noticed that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. The universe was expanding. For decades, scientists assumed that expansion was slowing down because gravity should be pulling everything back together. Then, in 1998, two teams of astronomers studying distant supernovae discovered something that defied every expectation. The expansion was not slowing down. It was speeding up. Something was pushing the universe apart, and it was stronger than gravity. They called it dark energy. Dark energy is the single most abundant thing in the universe. It makes up roughly 68% of all energy and matter combined. And yet, we have almost no idea what it is. The leading theory treats it as a cosmological constant, a fixed property of empty space itself. Every cubic meter of vacuum has the same tiny amount of energy, and as the universe expands and creates more space, there is more dark energy pushing things apart. This model worked perfectly for over 2 decades. It matched every observation. It anchored the standard model of cosmology. And then the DESI data arrived. The Dark Energy Spectroscopic Instrument, mounted on a telescope in Arizona, spent years measuring the light from over 40 million galaxies and quasars. From their redshifts, it built a three-dimensional map of the universe spanning 11 billion years of cosmic history. It is the most detailed map of the large-scale structure of the cosmos ever created. When scientists analyzed how the universe expanded over that vast timeline, they found something unexpected. The rate of expansion was not consistent with a cosmological constant. The data suggested that dark energy was stronger in the past and has been weakening over time. Not dramatically, but enough to be statistically significant. If dark energy is truly weakening, the implications are staggering. The cosmological constant, the version of dark energy that has underpinned our understanding of the universe since 1998, would be wrong. Not slightly wrong, fundamentally wrong. A weakening dark energy means the expansion of the universe could eventually slow down, stop, or even reverse. It opens the door to entirely new physics, forces and fields we have not yet imagined. Some physicists have proposed a form of dark energy called quintessence, a dynamic field that changes over time. Others have suggested our models of gravity itself may need revising at cosmic scales. Until now, the most likely fate of the universe was the Big Freeze, a slow, cold death where dark energy pushes galaxies so far apart that stars burn out, black holes evaporate, and the cosmos becomes an infinite, empty void. But if dark energy weakens enough, that future may not happen. Instead, gravity could reassert itself. The expansion could reverse, pulling everything back together in a catastrophic event called the Big Crunch, the universe collapsing back into a singularity. Or something stranger still, a cyclic universe that expands, contracts, and begins again. The DESI data does not tell us which fate awaits, but it has reopened a question cosmologists thought was settled. DESI is only partway through its survey. Over the next several years, it will map tens of millions more galaxies, pushing the precision of its measurements far beyond what we have today. The European Space Agency's Euclid telescope, launched in 2023, is conducting its own independent survey of the dark universe. And the Vera C. Rubin Observatory in Chile will begin a decade-long scan of the entire sky in 2026. If all three confirm that dark energy is weakening, it will be the most important discovery in cosmology since the Big Bang theory itself. We may be living at the exact moment when humanity first realized the universe is not what we thought it was.